Our team member consists of 4 people, namely Lim Kian Wei, Muhammad Nazrin, me, Nur Najiha, and Dme Assg. Here is the introduction. A helical reducer is a device that regulates a machine or motor output speed. It has 2 primary goals: to multiply the amount of torque generated by an input power source to reduce the input power resource speed and amplify the amount of effort to attain the desired output speed. Next is the characteristic. The direct connection of the motor is used. The construction is a first stage helical gear plus a first stage worm gear drive. The output is shaft mounted and come in 6 different configurations. It can move forward and backward. The features are space saving, low energy consumption, low vibration, high quality, and equipped with various types of motor. The advantages of helical gear used for high-speed application: parallel and non-parallel shaft can be used. They are creating less noise. Next, the benefit are high manufacturing costs, the need to use lubricant, and reduce power loss.
This is the bill of material, which consists of a total of 18 parts altogether. In the next slide, we will show you a short video of exploded view. In this slide shows the element of one-stage worm gear reducer. The first one is the helical gear set. The function is to reduce speed and increase the torque between turning shafts. The second one is the radial ball bearing. The function is to reduce the rotational friction force, while also supporting radial and axial stresses. And the last one is the output shaft. The output shaft is the transmission part that transmits power to the wheels. This is the detail of the helical gear set, which consists of elastic modulus, Poisson ratio, tensile strength, gear strength, tangent modulus, thermal expansion coefficient, mass density, and hardening factor. Next is the radial ball bearing, and the last one is the output shaft.
Okay, so here I will show how to generate the FEA analysis on the helical gear set. First, we need to apply the material on the shaft with NC316 and a stainless steel bar. Then click OK, apply. And also apply the material on the helical gear with the same material and apply, close. Next, we need to apply the gobbler interaction with bonder mesh independently at the definition. Make sure this helical gear set was in bonded and click OK. After that, we need to apply the fixed feature by select the surface at the helical gear and click OK. Next, apply the fixed hinge on the surface of the helical gear shaft, then click OK. Next, we need to apply the external load by using the torques. So we will apply the face on this area, the helical gear shaft, and also the same surface at here with the 1500 Nm, and then click OK. After that, we apply the mesh control by selecting the surface that will contact between the helical gear. Then set the mass density to fine and click OK. After that, right click and create the mesh and then click OK. Then run this study. Okay, so here is the one misses of the helical gear set after carrying out the FEA analysis. So this is the result of the stress analysis with one misses. Then this is the displacement analysis result for the helical gear set, and this is the strength analysis for the gear set. Then we go to the result, right click and select define factor of safety float and click OK. And this is the factor of safety of the helical gear set. Okay, so next is about the radial ball bearing analysis. First, we need to apply the material on the bearing. So we will select the NC304 material and apply on it. After that, go to fixture, right click and select the fixed geometry. Here we will select the fixed geometry on the outer surface of the bearing and click OK. Next, we apply the load and select the torque. Here we apply on the surface of the bearing, and here we will select the axial of the bearing with 1500 Nm and click OK. Next, right click the mesh and run. So this is the result of the stress of the ball bearing formulas. And then this is the displacement analysis on the radial bearing. And this one is the strength analysis. And we'll right click the result. We find the factor of safety. Click OK. So this is the factor of safety of the radial bearing. So if we go to the strength analysis, we run the animation. So this is the stress analysis on the ball bearing will be occur. Okay, so next is the driven shaft. First, also, right click to apply the material. So we apply the NC304 on this shaft and click apply. Next, go to fixture, edit the definition. So here we will apply the fixed fixture on these two surfaces. Because these two surfaces will be attached to the bearing, so we will fix it here. Then we will go to apply the external lock with torque. And here we will apply for the axis, and we apply the torque with 1500 Nm. Then we will click OK. After that, we'll mesh and run. So this is the stress result for the shaft after deform, and this is the displacement result for the driven shaft. This is the strain result of the driven shaft. And right click the result, define the factor of safety and click OK. And this is the factor of safety of the driven shaft.
Possible failure mode on the case study. Firstly is heat and oil leakage. Worm gear reducer often employs non-ferrous metals as worm wheels and more rigid steel as worms to increase efficiency. For the worm bearing damage, the gear oil in the reducer is frequently emulsified and the bearing are rusty, corroded. Proposed solution for the case study. Firstly, use suitable gear. Apply the gear with suitable material that can increase efficiency and improve heat resistance. The second solution is maintenance. Every machine needs to do maintenance once in a while to make sure every single component inside the machine is in a good condition. Make sure the gear and the bearing are not rusty. In conclusion, one-stage helical gear reducer is a system that is geared and also motor to function. From this assignment as a team, this course of designing the machine element also gave us the skills to assemble and disassemble the gearbox while doing learning in the laboratory. From that, we managed to know the name of the part as well as the function of each part. After designing, each component will be performed finite element analysis (FEA) to determine the yield strength, displacement, strain, and factor of safety (FOS) of the component. That's all from us. Thank you so much.